Here we're going to go through the steps to add or subtract rational expressions. And rational expressions are just fractions. And these fractions both have different denominators. So our first step is to factor the denominator so that we can see what the least common denominator is and change it so that they're the same. So if we factor the one on the left, to refresh your memory, we're looking for two numbers that multiply to give us the last number and add to give us that middle coefficient. And if you go through the options, you see that it's positive 2 and positive 1. So what I'm going to do is I'm going to erase this and put the factored form instead. Now let's do the same for the other fraction. Two numbers that multiply to give us negative 5 and add to give us negative 4. That would be negative 5 and positive 1. Now let's take a look at what is in the denominator. We want the denominators for both of these fractions to be the same, and we can add something to the denominator of a fraction, but we can't take something away. So you notice that they both have an x plus 1. That's good. But the one on the left has an x plus 2, and the one on the right doesn't. So we need to add an x plus 2 over here. And the one on the right has an x minus 5, but the one on the left doesn't. So we need to add an x minus 5 to the denominator over here. So to do that, what we're doing is we're going to multiply both the top and bottom, the numerator and the denominator, by x minus 5, and multiply over here by x plus 2. So now if we look at the bottom of each of these fractions, the denominator, we see that it's the same. That is called the least common denominator. So for both of them, it is x plus 1 times x plus 2 times x minus 5. So since the denominator is the same, now we can subtract. So we are going to subtract our numerators, and then we're going to keep the denominator the same. And now we're going to simplify. So in order to do the subtraction in the numerator, what we need to do is multiply each of these set of binomials. So we're going to use the FOIL method. So multiply the first numbers. So here I get x squared, the outside, the inside, and the last. So let's do the same for the other set. Now we are subtracting this whole thing, not just the x squared. You just can't put a subtraction sign here. We need to subtract the x squared. We need to subtract the 2x. We need to subtract the negative 3x, which makes it plus 3x. And we need to subtract the minus 6, which makes it plus 6. So now let's leave our denominator as x plus 1, x plus 2, x minus 5. So since we have distributed that minus sign to each of those terms in the second set of binomials, now all we have to do is combine our like terms. So when we're combining like terms, I see that there's an x squared minus x squared. That's 0. So I'm just going to cross that off. Then how about just the x's? I have negative 5x plus 6x minus 2x plus 3x. And that gives me 2x. So let's cross those off. And then how about our coefficients? I have negative 30 plus 6. And that gives me negative 24. And then again, my denominator stays the same. So after you have combined the like terms in our numerator, we're going to do one more thing. We want to see if there's anything that we can cancel out that's in our numerator and also in our denominator. So take another look at your numerator, see if you can factor it any further. And 2x minus 24, they're both even. I know I could factor out a 2. So this is the same as 2 times x minus 12. Now, the reason this is important is if there happened to have been an x minus 12 in my denominator, then I could just cancel those out, and that simplified it more. That's not the case here. The denominator is still that x plus 1, x plus 2, and x minus 5. So this right here then would be our final answer.